Fellow math students, it's Dr. John with another trig identity for you. For these identities, we're going to use these fairly simple steps here: trig definitions, double angle, Pythagoras, and difference of squares. For more complex trig identities, you may have to use other principles as well. But let's just start with these. Take a look at this. We've got two sides, a left-hand side here, and a right-hand side. Often we'll take the more complicated side, move it into the other side, or the other way around, left to right. But in this case, we've got things on this side and things on this side. So sometimes you'll do them both at the same time and meet in the middle. So let's take a look at the right side here. This one is the easier side to deal with. If you remember your double angle identity for sine theta, sine 2x is equal to 2 sine x cos x. We're going to use that right here and then divide by this. Divide that all by this, which is 2 cos squared x. So notice here, this down here, this I've replaced with this up here. Sorry, I switched the x for the thetas. The 2 cancels with the 2. One of the cosines cancels with this. We're left with sine over cosine or tangent. So this right-hand side here, this whole thing becomes tangent theta. I just write that in here because we're going to need the rest of the board for the left-hand side. As we're looking at for the left-hand side here, take a look at this. This looks sort of like the beginnings of a difference of squares, one of the 4 principles that we're going to use for solving this. To have this as a difference of squares, it would have to be 1 minus cosine squared theta. So what if we multiply the top and the bottom by 1 minus cosine? It might be a little messy. Let's take a look to see what happens. I'll write this out as neatly as possible. 1 plus cos theta. I'm just repeating what we have here. Now, multiply, we'll extend this. We're only dealing with the left-hand side here. So we'll extend this here to being 1 minus cos theta times 1 minus cos theta. Let's just deal with the bottom. I'll change colors. Use this handy dandy pink. So this is 1 minus cos squared theta. If you remember your Pythagoras Theorem, sine squared plus cos squared equals 1. Move this to this side, and we get sine squared equals 1 minus cos squared. So all of this here is sine squared theta. Sine squared, that's the whole denominator here in this giant mess. So I'll try to rewrite this denominator, all of this, just as sine squared theta. Now let's take a look at this top here. I'll move this over to here. Each of these terms. First term times the first term gives us sine theta. The first term times the second term gives us sine theta times cos theta, minus, I'm making it bigger here, this term times this one is tan theta. This is all in one line. And this times this is tan theta times cos theta. There's a minus sign there though. Thanks for catching that. All right, we have 4 terms. Let's put these all into straight out sines and cosines so we don't have this mixture here. This first term is sine theta minus sine theta cos theta plus sine theta over cos theta minus, this would be sine over cosine times cosine. Oh, whoops, that's just left with sine theta. All that's left here is sine theta. So we have a minus sine theta and a plus sine theta. All we're left with is these 2 terms, which I'm going to have to write somewhere, but it might get a little confusing. So what if I erase this pink and rewrite this up here, changing colors here. So I'm going to have this, that's this term, minus sine theta times cos theta. All right, now we've got this sine over cos, and sine times a cos. So what if we try taking out a common sign there? We'll take out a sine theta, and that's 1 over cos. I'm just going to rewrite that as secant just to keep it a little neater. Minus cos theta. Remember, all of this is divided by sine squared in the bottom here. So I'm going to take this now and put this all over under here. Sine squared theta. Here we have a sine squared and that, so we're able to cancel that. We're left with secant minus cos over sine. I'm going to rewrite that over here so we have room to work with it. we've still got a little bit of a mess here. Let's try multiplying the top and the bottom by cosine here. Just going to try something here, see what happens. Multiply this by cosine theta and this by cosine theta. We're going to get secant theta times cosine, secant theta times cosine theta, minus cosine squared theta, all over sine theta cos theta. Theta. They're getting a little messy. So if you happen to know, secant means 1 over cosine. So this is 1 over cosine times cosine, or 1. So this here is the same as 1. Move to this side here again. So this is, all of this is 1. So that's 1 minus cosine squared theta, all over sine theta cos theta. This here now reminds you of Pythagoras' theorem. Sine squared plus cos squared is equal to 1, or 1 minus cos squared is sine squared. So this is all sine squared on the top here. Theta on the top there. Now we have that there and that there. We're left with sine theta over cos theta, which was the right side, which was tangent theta. This one is a gigantic mess. I'm sure there's a simpler way to do it. I just walked my way through it with you here and came to an answer. So if that helps, like and subscribe, and check out my next video as well. Bye-bye.